Hi guys, welcome to the hierarchical indexing lecture. Hierarchical indexing is another very important feature in Pandas. It makes it possible to have multiple, two or more, index levels on an axis. Somewhat abstractly, it provides a way to work with higher dimensional data in a lower dimensional form. Let's start with a simple example of series. Let's jump onto the new notebook and start with importing NumPy and Pandas. Import NumPy as NP, import Pandas as PD, run these cells, and let's create a list of lists for index. Index equal to, say, the list A, A, and another A, and then B, B, and another B, and then C, one more C, and let's add D and another D. So, and the second list is 1, 2, 3, 1, 2, 3 again, 1, 2, 1, 2. So, what we want A, B, B, C, D as an index for our level 1 and 1, 2, these numbers as index for level 2. So let's run this thing here and see how the index looks like. Here we have index. So let's create a series SER using pd dot series, and then we can use NumPy's capability of generating random number np dot random. Remember, you have to call randn from random in NumPy. So np dot random dot randn, and then pass in 10 random numbers we want. So this is our data for series, and now we have to set index. And what is our index? Which is index. So once again, let's have a quick look. np dot random dot randn is generating 10 random numbers as a data for our Pandas series, and index, which is our list of lists, is going to be the index for our series SER. Let's run this cell and see how the SER looks like. So here it is. This is our output. So we see our series SER has two indexes, A, B, C, and D. 1, 2, 3, 1, 2, 3, 1, 2, 1, 2, and these are our random numbers generated by randn. So with a hierarchical indexed object, so-called partial indexing is possible. This enables the concise selection of subset of the data. Like if we select A from our series, so we are actually selecting this part. If we are selecting B, we are selecting this part because B and this 1, 2, 3 is the sub-index for B. So for C, we are selecting this part. Let's try SER A. So here we have. So we have this part with only one selection, which is A. We can further select this value, say, by simply passing, say, this 2 here and 2 here. So what we have in the output, 1.627. What we are doing, we are moving from level 1 to level 2 and grabbing an element from the series. So this was hierarchical indexing with series. Let's try another example with data frames. So with data frame, either axis can have a hierarchical index. Let's create a data frame here. df is our data frame, pd dot data frame, and let's again use numpy's a range here, np dot a range, and we want 12, and let's reshape this to say 4 by 3 matrix, and set the index equal to say a a b b, and the second one equal to 1 2 1 2, and then set the columns equal to say AB, ON, and say BC. Let's move this back to the same line. What we are doing, we are creating a data frame using numpy's arange method, generating 12 numbers, reshaping them into 4 by 3 matrix, and passing list of lists as an index and list of strings a, b, o, n, b, c as columns to our data frame. Let's run this cell and see how the data frame looks like. So here it is. So we have a data frame now with level 1 index a, b, and level 2 index 1 2 1 2. We have multiple indexes on rows, whereas columns are a, b, o, n, and b, c. So now the question is how to index this data frame. On column axis, we just use a normal bracket notation with data frame. For example, df, and pass in a, b, and run this cell, and we are getting a, b, and the level 2 index 1 2 1 2, and the column a, b 0 3 6 9 0 3 6 9. And in the similar way, if we want BC, we are getting 2 5 8 11 in the output. What if we want the rows as well? On the row axis, we use LOC. Like if we want rows, df dot LOC, and then in brackets we pass in say the A here or B here. Let's pass in B here and run this. So we have this portion, this subset of our data frame, B 1 2 6 9 7 10 8 11. So what if we want to grab a single value? The idea is to go from outside to inside. For example, if we want to grab 5 here, the first step is to grab A and this whole set. Let's call, instead of B, let's call A here and run this cell. So we have 1 2 0 3 1 4, and now we want 5. So on this one we have to call LOC again, and what we want to grab 2 here, and after 2 we want BC because the location for 5 is 2 BC. So what we want to pass in 2, and then which column? BC. Let's run this cell. So we are getting 5 in the output. So just a quick overview on this line. The idea is to go from outside to inside. So first we are moving from outside and grabbing a portion or a subset of our data frame using A, which is the level 1 index. And after that, when we have the subset of our data frame with A, we are using LOC on that subset to locate the value 5 here. So moving forward, the hierarchical levels can have names as strings or any Python objects. If so, these will show up in the console output. And we can use index.names on our data frame to get the list of those levels. So let's call this index.names on our data frame df. So we don't have any names for our levels in the data frame. Let's give names to these indexes. Let's name them level 1, say L1 and L2. We can use df.index.names and set it equal to a list L1, L2. So we are naming the levels L1 and L2. Let's run this code and run this df.index.names again. So now we have the names for our indexes level 1 and level 2. Let's see how the data frame looks like now. Here it is. We have given the names to these indexes. L1 is the level 1 index, L2 is the level 2 index. We can select any name according to our convenience and based on the data what we are working with. So moving forward, it's very important to introduce another very useful function, XS. XS has ability to go inside a multi-level index. This returns a cross-section, which is rows or columns, from the series or data frame. Let's call XS on our data frame df. df.xs and pass in, say, A here. So now, what we are getting a subset of our data frame for index where the level 1 is A. This one is a very easy example. Let's talk about another one which is little complicated. If we want to grab all the data in data frame where index level 2 is 1, like in this case, if we want to grab the first row, this one and this one where level 2 is 1, it is tricky for LOC method, but XS will do the magic here. For example, we tell XS what we want in the output. So here we want level 2 where all is 1 in the output. Let's call XS on data frame and let's look at its document string. Here we have key, which is some label contained in the index, and we want 1 here, and we want to mention the level here as well. So let's pass in key equal to 1, level equal to L2, and run this cell. So here we have. So XS does the magic in this case. So guys, this was all about hierarchical indexing. I hope you got a very good understanding and idea about the multi-level indexing and how to grab data from multi-level indexing. Once again, the idea is move from outside to inside. So see you in the next lecture where we will talk about handling the missing data. Good luck.